Hello folks, welcome to Land Timber Stream. It is Wednesday and we're going to be talking some more spanning tree stuff. In particular, some of the optional features of spanning tree, some of the protection mechanisms. And I'm going to go over Even G and its ability to, a really cool feature that I'm still learning but I really like. And it is the playing with different configuration sets in Even G, really slick. So I'm going to go over that too. If you haven't used that yet, if you have an Even G, you may or may not have used this feature, but we'll talk about it. Yeah, I had a little trouble with my virtual machine here a second ago. It was taking forever to close, and I was missing I was getting a lot of lag, but it looks like that's fixed, so that's good. Hope everyone's having a great Wednesday and getting things done and learning new things and all the good stuff. So let's go over the agenda here, folks. Let's see, we've got the chat window. Yep, chat's up. Make sure chat's working. Yeah, and I'm also going to pick up a little bit where I left off on the multiple spanning tree, because I had some questions about that, sort of things that I didn't really understand. I think I have a better understanding of that now, and I'm going to go over that as well, just to make sure I can explain it. So let me update one thing here, the description. Man, I had to scramble to get ready. I had some errands to run and just scarf down some food, but 7 p.m. we're ready to rock. I've been going over, this is a crawler launcher shot. It's pretty cool, wallpaper of the day. Hey, we have Bashy Mashy. Thank you so much for that resubscription. I really appreciate it, for your 2-month sub. Always appreciate the support here. Good to have you, my friend. And Bashy Mash, I know, has been doing great on studies as well, knocking some things out, active in the Discord, and we got a great community here. Discord's been great. We've had some good conversations in there. We've had some new people coming in, but thanks again, Bashy Mashy. Sending you nothing but good bits tonight. Yeah, so network. This is the crawler launcher. This is near, let's see, it is 30 Launchpad or LC39B, I believe. And it is 2 parts here. You have the crawler, which is this big, like, monster. And then you have this launcher that sits on top of it that they move. I don't know, it's like not even 1 mile per hour. But that's how they move that thing. It's pretty cool. I've actually seen it in person. When you do there's a couple tours you do at Kennedy Space Center. There's one where you can do a bus tour, and they will actually show you this thing. It's really cool. So yeah, folks, I've been working on networklessons.com, and I've been going over the spanning tree. I can actually pull up where I'm at. I got through a few after work today, and during lunch, I got through a couple of new lessons. I kind of let MST go. I'm like, okay, I pretty much got it. I have some unanswered questions, but I could not find any answers anywhere, so I'm just going to let that go, keep on rolling, and I'll show you where I'm at here. So if I go to the RNS written, we've got our layer 2 technologies. I'm really trying to get through spanning tree and get to multicast. So we are now on, I wrapped up MST and PVST interoperability. So now today I did BPDUguard, BPDUfilter, loopguard, and udld. And one thing I learned about this, folks, is I've overlooked this before, but at the end of an article, let's say you do it on spanning tree and PVST interoperability, at the end it'll have like 1 or 2 like questions that come up. Like there's some people here, right, and they're asking about the lesson. And you can go to the community forum, and man, there's some good stuff on there, because generally if you have a question about a lesson on networklessons.com, you can post a question, and either Renee or some other pro will answer the question. Like, it's awesome. So obviously, I don't know I haven't submitted a question yet, and the cool thing is you can go and read all the old questions. Some people ask really good questions. Some of these questions are things that I was wondering about, and there we have it. There's the answer. So it's just another great thing about networklessons.com is the forums that you get access to whenever you join or subscribe. So, you know, I'm just a regular paying subscriber. There's no kickbacks for me, anything like that. Like, I'm just telling you my honest opinion about the product. And I'm saying the community forum is something I've overlooked before. I'm not going to do that anymore. I had some great questions. In fact, one of our trivia questions, well, this trivia question for tomorrow comes out of that forum question. Comes out of something that someone asked in the forum and a statement made. In fact, it was cool. Someone asked a question, and Renee came back, who's the owner of neverglasses.com. He came back, you know what? He said, I wasn't sure, so I labbed this up myself. And here's what happened. What more could you ask for, folks? I mean, that's a great feature. So anyway, that's where I'm at right now. Again, I'm trying, man, I hope next couple days, at least by the weekend, I want to get to multicast, layer 2 multicast. Got to. But I'm going to do a couple little labs here today just to, this is for me, it's not just for the viewers of the channel, although, you know, you may or may not find this useful. The first thing I'm going to do is I'm going to go back and I'm going to reload the multiple spanning tree lab that we had yesterday. And I let this running, this VM was running all night, all day. I actually hopped on it like during lunch today because I kept it running. I probably won't do that anymore because of this other feature I've learned how to do properly, which is manage the configuration sets. So this is going to be kind of a combo lab here. We're going to go back to that question I had about the multiple spanning tree from yesterday's lab that I did not figure out. And we're going to talk about these configuration sets. Now, config sets, while the lab is loading, if you go to the EVNG cookbook, now this is a professional cookbook. I know it works for a lot of the other features that are not in the pro version. I am running the pro version. They're actually, I don't know if it's a year license, but they gave me a license, a temporary license to use to just sort of try out. Obviously, there's coverage of it here on the stream, so just let everyone know that. But there's some really cool features here. And again, I do not know. It doesn't really distinguish on here whether this works just for Pro or for Community Edition. There's actually another edition too, a Lab Edition or something like that. But we're going to go through this because what I want to do is I want to take this lab topology I have. I built this topology really in particular for the multiple spanning tree. And I want to create 2 versions of the configuration sets. So I want to have one set that is for, because I may come back to this, I want to have one set that is for the classic spanning tree, or PVST, being the root bridge for all VLANs. That's where we left it last night. So that is up now. Let's go to, I know I do this a lot, folks. I'm sorry. That's just like nervous energy. I used to do this thing on the keyboard where I would, you probably can't, I know you can't hear me, but I would just kind of tap the keys when I was thinking about something. I would tap the keys without actually pressing down on the key enough. It would drive my coworkers nuts, man. Like, Quentin, stop tapping the keys. I don't do that anymore. All right, so let's go to well, actually, we need to do this in Chrome. Chrome is a preferred, at this point, Chrome is a preferred browser for Eve. So I'm using HTML5 console. I have this small because the topology right now is small. Okay, this is the lab I left up, which I like. So EVNG, what it does is it leaves, like, whatever lab you had open, when you shut down to even bring it back up, that lab is still open. It's not running, but it's open. So what I'm going to do is come here to more actions. And let's go to, actually we're going to go to startup config. So what is everything going to start to? Which config set? And I'll go over creating these in a minute, but this is multi-spanning tree PVST. And all we have to do here is say, we click this lightning, and it's going to set all nodes to this collected config set. And what's really cool is, I didn't realize this until I looked at the cookbook a little earlier, is you can actually select, so if you want to see what this config set is for this device, you just click on it. We actually need to check switch 5, because switch 5 should be the lowest priority, and it is. Okay, that's what we want. You can even edit in here. Let's say you didn't like this. I can edit it. I can upload configuration files from my hard drive, my local hard drive. I can also download the configs here. So cool. I really like this. Oh, they're already unzipped. Ah, come back. Where to go? Downloads. I need to change that folder. Check it out. That's slick, man. That's so easy to work with. There we go. So we have our, awesome. So that's what I want to boot to. So I'm going to go back to, these are my startup configs now. Now we're going to start all nodes. And again, what we want to do here is, let me adjust my screen a little bit here so I can see people. See any chats that come up? All right, so while this is booting up, again, what I was talking about doing is, so last night I had switch 5 become the root bridge for all VLANs, which is all fine and good. We had to, of course, what you have to remember is VLAN 1 has to remain the superior BPDU above any other VLAN. So we have to set the priority lower on all the other VLANs. And they have to be lower than you know what VLAN 1 has, which we're doing here. So if we go back to our downloads folder, and we look at switch 5, pull this up again. So as you can see here, we did VLAN 1 is priority 4096, and the other VLANs, they're VLANs 2 through 9, are priority 0. Because remember, with PVST, it adds like the VLAN number to the priority. So it makes it like 4097. Then the next BPDU for VLAN 2 would be 4098, which would be an inferior BPDU. And this is all good. Like I set up on switch 5, I have an SVI on VLAN 6, and then I have host 1 has an interface on VLAN 6 here going this way, so it has to go through the switch fabric. And it works. They're able to ping each other. And that's all good. Now, the question I had is about what the root bridge looks like on switch 1, switch 3, and switch 4. Switch 2 looks legit, and we're going to go to him in a sec. We're going to do that here. Yeah, I'm just going to open and, well, let's do, I'm learning to use these additional menu options here. One is console to all nodes. So easy. Why didn't I use that before? I don't know. Maybe because I didn't know it was there. They need to call it something else other than guacamole. That can make a person hungry. Connecting to guacamole. Oh, really? Okay, let's see if it's supposed to pull in our configs here. And where is switch 5? We got switch 1, 2, 3, 4, and H1. Where's switch 5? It's looking good so far, by the way. It's looking like based on like this switch is administratively down, these are up. Oh, switch 5, where did you go? Okay, he probably came up first, yeah. So show span VLAN 1. Okay. Maybe when I exported the configs, okay. It might still be converging. Probably is. These switches are still coming up. Yeah, it must be. Still converging. Yep, received. Okay. Oh, inconsistent port type. Interesting. All right, we'll figure it out. We'll see what happens when everything comes up. And let's move switch 5 right there. All right. Show span VLAN 1. This bridge is the root. Show spanning tree MST config. Okay, that looks correct. Except, okay, I think that's fine. Where we need to check it is switch 2. Yeah, it's saying GI00. All right, this is a boundary port, PVST. It's not showing inconsistent, but it is showing it as designated. So it still thinks that the root switch is... Oh, let me check the cost. Show spanning tree. Okay, costs for port 8, alternate blocking, GI13. Okay, it's interesting. So this time, all right. So what I'm seeing here is that switch 1 is the root bridge. The priority is 32769. But switch 5... Let me make sure that it actually loaded the correct configuration. It did not. Okay, so as you all can see, even though I told it to load... All right, it did not load the config set that I wanted. Well, that's a bummer. Why did it not do that? Why did it do that? See, what we need to do here is spanning tree VLAN 1 priority 4096. VLAN 2 through 9 priority 0. debug span events. And we're going to do here also debug span events. This should work. Okay, VLAN 2, yep, we have a transition here. Now we go into forwarding. And switch 2 is sending out these TCNs. So we're going to age out MAC address table. Or reduce the aging time. And we are going to send switch 5 as a root bridge is going to send topology change BPDUs on all designated ports for 35 seconds. Okay, now he's saying, look, I am the root bridge. Yep, these ports are designated. And all the world should be good. So now if we go to switch 2, we want to look at our boundary ports. There we go. So this is, okay, that looks good. In a second, I'm going to kind of go over my conundrum here. Excuse me. This looks legit, right? Because this is a boundary. This is our PVST simulation boundary port. And we are blocking. And really, route 2 here, or switch 2, this is the root port. So if we think about this in terms of PVST, switch 5, these will be designated ports, and this is an access port. So these will be designated. This will be root, and this will be root. Or should be, GI1, 2. Interesting, it's alternate. So let me think about, why is that the alternate port? Oh, okay. The thing is so the whole region is being presented to switch 5 as a single switch. That's right. So the simulation, what it's going to do, this is a boundary, and it's going to select the best port, and the other is going to be an alternate. Let's actually look at the BPDUs coming in and out of GI13 and GI12. So let's take a look at those. That didn't scale very well. Note to self, make this window larger before you, actually, let's redo that. GI13. Yeah, it's hard to really know like exactly what's going on behind the scenes when you have PVST emulation at work here. That's what I've been able to conclude, I think. So we want to just see what is being sent. Actually, we'll stop it there. All right, so this is switch 5. And he is sending a regular good old BPDU 4096 for VLAN 1. Okay. Now let's see what we have on switch 4, GI12. Probably not much because, okay, it's still listening, but it's in blocking mode. Okay, this is for VLAN 6, right? We should have one for VLAN 1. Here we go, 4096. So why would this not be root port, and this would be an alternate 2 or 3? Well, let's see if they are actually receiving. Let's see what they see here. What switch 2 is sending them on. Let's see, what is a port marked as for VLAN 1? Alternate. Okay. Well, it should be listening. Let's see what it receives from switch 2. Let's look at GI02 here. And again, it may not be possible to really determine what's happening under the covers with this PVST plus simulation. I'm afraid that's what we're going to come to a conclusion of. Okay, so all it's getting is the MST BPDUs. Okay, so what's happening here is this is running spanning tree mode, MST. So it is sending, I think it's sending. I want to, no, it's not. Yeah, so it's marked it as blocking. So essentially, this becomes like it's going to act like a single switch. And I've got 2 ports to this single switch, right? So this single switch is only it's going to put 1 port as a root and the other is alternate. Okay. That's essentially how that's working. Got it. All right, let me draw this out. So we've got switch 1, 2, 3, and 4, and switch 5. And this is treated as a single big switch, right? So even though we physically connect two different ports, this is going to be treated by PVST simulation software, however that works, as a single switch. The entire region is treated as a single switch. So just as any other single switch has two ports connected to the root, one of them will become the root port and the other one will become an alternate port and blocking mode, right? Okay, it makes sense now. I know I've read that, but it's weird when you actually see it on the switch. When you run these commands, it takes a little bit for them to congeal, for me anyway. And it's confusing to look at when I use the classic commands. Now, if I do show span mst 0, as a matter of fact, we do that switch 2, right? Regional root, this switch. Oh, you know, I did not notice that before. So when we look at our drawing, we have to have our regional root. Even though this would normally be switch 1, because switch 2 has determined that he has the root port to the root bridge. He is the regional root. So what does that look like over here? Regional root this switch. Yeah, I missed that before. That would have helped me. And that's why we have GI13 as the root port and all the others are designated. So that somehow it signals that. How does it signal that? Does it do that via the BPDU? So switch 2 is sending these down to switch 4. It must be in here somewhere. I was trying to get under the cover. See, there's 4096.1. That is the root identifier. MST extension. CIST bridge identifier. CIST bridge priority. Regional root. Check it out. Boom. Now that's for MSTID number 1. So that's how they're letting each other know. Regional root is switch 4. That is correct for MSTID number 2. Okay. So what is up here? This is saying we're running MST. BPDU type is rapid MST. BPDU flags. Root identifier. That is the root for the IST, I guess is what it's saying. And then it goes into the MST extension. Hey, blind hacker. Thank you for that raid, my friend. Appreciate it. Yeah, man, we're getting our... we're trying to finish our painting here, like Bob Ross. We're looking at multiple spanning tree. Hope you had a great stream, Blind Hacker, today. Thanks again for that host. And again, yeah, we're talking about multiple spanning tree, which is switching technology. Our remaining hops, MST, yeah. So regional root, interesting. So here's what we have here, right? We've got, where'd my drawing go? Where's your drawing? Okay, so this is for common spanning tree or internal spanning tree or MST0. This is the regional root. Switch 1 is MST instance 1 is regional root. MST 1 and switch 4 is regional root for MST 2. Let's just confirm that. Let's look at switch 4, show span MST 2. The root is this switch for MST 2. What's interesting though is if you run this switch, and this is my question yesterday. Oh, hey, we got some chats. Sorry I missed the chats, folks. This has been happening with Firefox. Like, it hasn't been showing in my pop-up screen. All right, so mentors. Hey, mentors. Good to see y'all. Okay, so I'm going to go over this, mentors. All right, so here's how we configure it. What I did is I configured... So you always have, when you enable spanning tree, you always have the common spanning tree or IST, which is the internal. Let me make this bigger. You have the IST, which is the internal spanning tree instance, which is also IST 0 or MST 0, multiple spanning tree instance 0, right? Text is kind of weird. All right, and generally that is controlled by however you configure instance number 1. Your first spanning tree instance, right? So MST number 1, I assign to VLANs 1 through 5. And the way I did that is over here on switch 1. Well, you have to configure it unless you're doing VTP and you are synchronizing all your switches in the VTP domain for MST. It's configured on each switch. So I did show run show span MST configuration. So yeah, I mapped instance 1 has VLANs 1 through 5. And instance 2 has VLANs 6 through 9. Yeah. So what I did was, just for grins, is I made switch 1, I made him the root bridge for VLANs 1 through 5, or MST1, right? I'll show you that config. Yeah, revision 1, instance 1, VLAN 1 through 5. Okay, by default, VLAN or switch 1 is going to win, right? I don't actually technically have to lower the priority here. It's already going to win the root bridge election. For switch 4, I did have to specify a lower priority. And I'll show that to you. Yep, look here. Spanning tree MST2, priority 28672. All right, switch 5 is not running multiple spanning tree. Switch 5 is running PVST plus. So let's do a new text box. That's what this line kind of designates. And these 4 switches are in the same region, MST. Region. Right? So that is the difference. Yes, there you go. That helps, doesn't it? Yeah, and so what we're doing is I'm just trying to figure out the internals of. I was left unsure yesterday about how the internals worked with the spanning tree outputs inside the MST region. And again, these are all pretty much represented to PVST plus as a single switch. So PVST plus, this switch 5 thinks there's only one switch over here. And it thinks that that switch is switch 1. Because remember, when the decision is made, we're going to simulate PVST over here. It only uses IST, or instance 0, to make that comparison. So even though switch 4 is the root bridge for MST2, we're only using MST0. And switch 1 is the root bridge for MST0. So when we look over here at switch 5, well, he is the... Yeah, he's the boss. This bridge is a root. So kind of going back to what do our BPDUs look like, we have these regional roots, and what really looks confusing is when we go to switch 2, for example, show span, and we're going to run the PVST command, right? Encapsulation is another way to think of it, and switch 1 is the parent and the others are the child. Yes, so when we look at the BPDUs, exactly, so we look at switch 2, right, he's sending the BPDUs on behalf of the region. Notice what the bridge ID is. So this is switch 2. Actually, he is not the root bridge right now, right? So he's not sending BPDUs. But in the initial negotiation, he did, and he would send... actually, let's reverse these. So we're going to reverse them. and we'll see that. So we're going to come back here. Spanning tree, VLAN 1, priority. Actually going to do no span VLAN 1, priority 4096. No span VLAN 2 through 9, priority 0. So we're going to have a little convergence, but notice, folks, what switch 2 is you might say encapsulating. What switch 2 is representing to switch 1, or switch 5, I should say. So he's sending over these PVSTs. But notice who he says is the root bridge, not himself. Yeah, it's encapsulating too. You might think of it as because even though switch 2 is running MST, it is simulating to switch 1 that it is running PVST plus, right? So it's sending the good old-fashioned BPDU over. And it's saying this is the root bridge, which is, and notice the path cost, 0. Message age, 0. So it's sending it as if it is using the link of the root bridge, right? Cool stuff. All right, now we're going to switch them back. Can I undebug here? Yeah, man, you got to think of it logically. So true. I mean, I agree. I like it. Like I've been telling people, you know, that's what Mentor says here. He says, I know I'm using improper terminology, just my way of understanding logically. And that's a good thing to do. Like, I think. Like, I've been trying to look at spanning tree as more sort of how a routing protocol acts. In terms of loop prevention, of course, which is main function, but also in terms of, you know, preferring one path over the other. Okay, I told it to undebug all. I guess it has to wait to get down there. Let's look at switch 4 too. I'm going to undebug all here as well. All right, this is where it gets a little confusing. Oh, we've got inconsistent. Why is that? I have not configured this yet. Yes, Mentors asks, are you learning from a Network Lessons article? I am. So the Network Lessons article was good, very good. There was a video in the lesson as well. It also had a number of really interesting forum questions about this particular subject. But there was a really good Cisco Docs article as well. And I can actually link these again. Let me pull up yesterday's agenda. Okay, what just happened? Firefox, you're acting weird, man. Trying to use you instead of Brave, but you're acting awfully strange. Yes, I do talk to my browser windows. They talk back sometimes too. So I had VS Code open, I thought. Maybe I was on... Okay, that's my fault. My bad. I had the Firefox window selected, not the VS Code app window selected. There we go. So this is the link on the Cisco has a really good article on this. Copy paste, VS Code. Have you heard of that? It's called copy and paste. Copy, paste. Okay, it worked. Never mind. So there's a good link. And basically everything that was in the network lessons is in this link, except for the video. But this is really good. But one thing that it explained well. All right, these are inconsistent. We're going to find out why here. Okay, I think I'm just going to stop the switch and start it again. Oh, you're very welcome, mentors. Happy to help out, my friend. Hope you're feeling better. Hey, we got another host. Blind Hacker hosted me again within 18 minutes. Wow. How does that work, Blind Hacker? I wondered about that. Like did you go back online on Twitch? And then you go live and then not go live? Like, did you just go live for 15 minutes? I was always wondering how that worked. I think it's cool. Okay, so what we're going to do here is we're going to wait for switch 5 to come up again. We're going to see why he's acting all antisocial. Kill that, kill that, kill that. Getting perkier indeed. Definitely things are hopping in the Land Tamer Discord. All the peeps streaming and sharing. So most definitely new viewers come and hang out with us in the Discord. Yeah, man, we've had a lot of good action in Discord. It's interesting, like someone brought up in Discord today about, I think it was today, like, hey, all the spanning tree stuff, I'm actually having an issue at work with multiple vendor switches going down, and you know, want to run multiple spanning tree, and you know, how do I kind of address? So yeah, this stuff does get used in real life, and it's interesting to see the interaction in Discord with people. You know, when we cover something on a stream, for example, and people interact, they're like, oh yeah, I've seen this, or I've seen that, or and it's good to strike while the iron's hot, right? While someone's working on it, because in a month, I don't know if I'll remember all these details. Okay, so right now, okay, so what we want to do is we want to make span tree VLAN 1 priority 4096 and span VLAN 2 through 9 priority 0. Okay. So switch 5 should become the root. And we'll just debug spanning tree events here. All right, this bridge is a root. That's right. And it's still learning. Now both those ports are designated. Countdown, getting close, buddy. CCI written. We recall all this info. I know, man. I got to get going too, mentors, because what I'm going to do is I'm going to reassess. Oh, Firefox is really letting me down. I may have to give up on Firefox. Like, it's been doing a cut. You know, I switched from Brave because Brave was starting to run like really slow. So I switched to Firefox as an alternate browser for the stream because I like to keep, like, Safari is my browser here for the Mac. Use Firefox Developer Edition. I may do that. I gotta try something, but Safari has like all my history. It has all, you know, I have like LastPass. Like, it's all set up for non-streaming stuff. But when I stream, I want a separate browser, sync to a separate account, separate bookmarks. And I was using Brave, and that worked pretty well, but it started to get really slow. Now I said, okay, well, let me switch to Firefox. And Firefox is doing some weird stuff, man. Like, it's... Anyway. All right, so here we are. Now switch 5 should be the root. And if we go to switch 2, show span VLAN 1. Okay, check this out. So this is cool. When I am on a boundary switch, in other words, when I am on a switch that is here at the boundary with the PVST simulation, okay, it shows me that ordinarily VLAN 1, right, would be switch 1. But the MST root switch is really this port going over to the boundary port. That guy is really the master, or the multiple spanning tree root. And that's cool. This all makes sense when you look at switch 2. When you look at switch 1, however, it is not at the boundary. Show span VLAN 1. Look at the output you get. So it's acting here like it knows nothing about the real root switch, which is switch 5. So how do we not have a loop here? Because we really have switch 1 thinks that it is the root for VLAN 1, when in reality for this entire domain, switch 5 is the real root bridge. It makes sense when you do show VLAN 1 on switch 2, but it does not make sense when you look here. What I'd like to see is, in fact, if you look at the ports, they're all designated as if this is definitely the root. And neither the Cisco article did not cover that, and the networklessons.com did not cover that. Again, as long as you look at a border switch, it all makes sense. But if you get away from the border, it's like, how is it that we have two root bridges for this spanning tree instance and not have a loop? So take VLAN 5, for example. If I look at VLAN 5 here on switch 4, yeah, it is confusing. So, mentors, so if I do show span VLAN 5, oh, sorry, 6. This bridge is the root. Right? So, but if you look at switch 2, he's saying, oh, 6, sorry. He's saying, okay, I know that for that spanning tree instance, that 4 is the MST. He is a regional root for MST number 2. Right? So that would be the root going that way. But in reality, this boundary port going to PBST, this guy is the MST root bridge. That makes sense. But when I look at 4, there's no way for me to really know. Well, I kind of get a hint here that we've got a boundary with PBST. But if I go over to switch 3, show span VLAN 6, my root port is switch 4. So how is there not a loop here? That I don't know. I've not been able to find an answer to. But you know what? I've determined that for what I'm studying for the written, that's okay. I know that the documentation states how PBST simulation works. It states how you configure either the non-MST to be the root and how to successfully configure the MST region to have the root bridge and properly interact with the PBST non-MST domain. And that works. We've demonstrated in the lab. The fact that the outputs don't make complete sense, I think we're okay with. I'm at peace with that. I have to be. I mean, I don't have time to dive into this a whole lot more. We're going to save this to the desktop. Save as device. Okay, it saved it there. I want it to go here. And this is MST drawing. Okay. So what do we have next on our agenda here? See that delay? Like it, that seems like a very small detail, but it means a lot. Now I need to dig deeper since I have more time than others. Thanks, buddy. This is going to drive me nuts. Hey, if you figured out, you know what I may do if I have time is actually post it on networklessons.com. Post that output. In fact, let me do this. Actually, we can come here. We can go to, let's export all configs. And I want to do a screenshot from switch 3's point of view. show span mst config. Do a screenshot of that. And we'll do a screenshot of this. I may post this just to see what Renee says. We'll drive him crazy a little bit. Desktop. How is that useful to me? Do I have to open this in draw.io? I find a new tool, it looks really cool, you try to use it, and then you find out it has some weird... So is this the default format it's going to save it to? That's no fun. Export as. There we go. Ooh, you can do VSDX. You can, okay, that's cool. All right, this is much better. Okay, screenshot of that. I'm going to save that for later and post all of that. All right. Yeah, well, I'll do that for sure, mentors. Okay, so something else I wanted to look at is I'm gonna kind of speed this up just for time. The config sets, that did not work right, so we're gonna have to go back on that. But bpdufilter. So now we're getting into some of the spanning tree additional, features. And, I looked at bpduguard, bpdufilter. And of course, with bpdufilter, you can, and we can test this in a minute in the lab, but you can, of course, configure at the global level. And what the global level, of course, does is that it enables bpdufilter on all port-fast configured ports, right? And what it will do is it will stop sending and receiving. Well, all right, there's two different behaviors, right? So when you configure it globally on a port and it applies to port-fast port, what happens is that it just waits to, it will not send BPDUs on that port. And if it receives a BPDU, that port will no longer be in port-fast mode. And I wanted to see what that looked like. So let's say we go to host 1. This is an access port. Actually, you know what we probably have to do is let's say between switch 1 and switch 2. Let's do it there. So what I'm going to do is I'm going to configure one of these ports. Let's say GI00. We're going to say switch port mode access. Port access VLAN 4. Okay, we're going to turn off debugging. And what I'm going to do is we're going to say that this port, we're going to put it in port fast mode. Well, first, let's see. Let's do a spanning tree port fast BPDU filter. What's the command here? Spanning tree port fast. Interesting. Oh, sorry, folks. I don't have my notifications off here. Wife's really tired this evening. Let's see. Edge. There we go. bpdufilter default. Okay, so this is our command. Okay, so we don't really have any port fast ports right now. So show interface GI00. Actually show interface GI0 switch port. Okay, so right now, oh, did we do, let's see. Interface GI00 switch port access VLAN 4. Access mode, administrative, okay, voice. Okay, and what we want to do is all right, since these are edge, well, I think we have to define that, right? Let's go ahead and put them in port fast mode. I want to capture traffic too. Let's capture traffic here on GI00. Let's see it in action. BPDUguard, I pretty much have that down, right? That's pretty much... Okay, it is getting... it is receiving BPDUs right now. Show interface GI00 switch port. Static access. Access mode, trunking native. Show interface trunk. Okay, remember though in with rapid spanning tree, you have to, it's still going to send BPDUs until you tell the port that it is port fast edge, right? So I'm going to say spanning tree port fast edge. I'm going to do the same over here. Show interface GI00 switch port. Let's see. Access mode, administrative, operational private VLAN, trunking. Yeah, there's no indication here that it's port fast, but if we do show span interface GI00. Okay, it is an edge port, so we should not really be seeing any, and we're not seeing any more BPDUs here. We can do show span base GI00 state. I'm looking to see the information about whether it is running BPD filters. Interesting. So if we look at this. Hey, thank you for the follow. Choo choo. Appreciate it. Welcome to the Land Tamer stream, and thank you for the support. Hope you're enjoying the content here. All right, designated route has priority. So looking at this port here is route forwarding. Oh yeah, we have detail on each spanning tree detail for each instance. Port fast edge mode. Okay. Yeah, we don't really. I don't know if there's a way to reset those timers or the counters, I should say. But anyway, these are in edge mode, and we do show span. I want to see detail about bpdufilter. Oh, you know, I have not looked at this detail command yet. Oh, there's actually a lot of information in here. This is pretty good. MST0 is executing the mstp compatible spanning tree protocol. Configured hello time, transmit hold count. I don't know what that is. That's a new timer I don't know about. Current route priority. Oh, look at this. I think this is it, mentors. So switch 1 does know about switch 5 being the root. It does know that. Currently, the topology change flag is not set. Let's stop and start this, by the way. Number of topology changes 100. Last change was 4 minutes 38 seconds ago. Link type. Number of transitions forwarding state. Man, there's a lot of information in here. We are the root of the spanning tree. We are, as if... That's funny way. Point-to-point internal, right. There's a hold timer on MST1. What's funny too is that as if it talks about itself as we are, not I am. So how many of you, you know, or what's your name? Is your name Legion? Like, what's going on here? We are the root of the spanning tree. Who is we? Who are you talking about, man? Interestingly enough, though, it does not know, in this case, for example, about MST0. PBST simulation is enabled by default. Okay. Anyway, getting back to the BPDU filter. So we're not sending or receiving any BPDUs on this port fast port. They do not forget, and we should expect them. Them. Plural. All right, so what we're going to do is to trigger this, we're going to go over here and we're going to say, we're going to change this from an edge port to a trunk port again. Show, let's first look at the show interface, GI00. Show span interface GI00. Okay, so either way, it should send information to him. All right, what we're going to do here is interface GI00, switch port mode trunk. Let's see. Oh, native. Okay, so it is sending CDP packets. I don't see those here, though. Am I capturing the right interface? Just to make sure. Let me... I want to see incoming packets on, or frames, on switch 1 GI00. Okay. So it is receiving from switch 2, it is now receiving BPDUs. So what will this look like? Show interface GI00 switch port. Where do we see it? How did we see that it said it was import fast? First of all, is the configuration still there? Yeah, the configuration is still there. Details. So show interface GI00 switch port. Oh, details, yes. Is that what you're saying, right? Mentors, use the details command. Or the details operand. All right, so we did show spanning tree interface GI00 detail. The port is in the port fast edge mode. So it doesn't really look like it. Show interface GI00 switch port detail. Switch port. Let's see, show interface. You know what we need to do is we need to debug. Debug spanning tree events. What is a switch shim debug command? That looks interesting. All right, let me go back to the network lessons real quick because it had an example of how to trigger this. bpdufilter. Okay, here's what I need to do, I think. It's just debug spanning tree BPDU. So that's what we need to do on this guy. Actually, what it says also is we need to pretty much shut down the other switches. Otherwise, if we debug spanning tree BPDU, it'll lock up the switch. So let's do that. And let's just turn off the other interfaces. So GI101. Okay. Yeah, we're just gonna have a single connection. Between these guys. Yeah, he's definitely receiving all right, let's change it to, let's just say spanning tree mode PVST plus. And we're going to go back to switch 2, just for simplicity's sake here. And as a matter of fact, let's say no VLAN 5, no VLAN 6, no VLAN 7. One VLAN. Let's see, no VLAN 2 through 9. Show run interface GI00. No switch 4 access, VLAN 4. Show VLAN brief. Okay. Good deal. So we should have really just one active port here. Show interface status. Okay. There we go. Switch to all right, one port is up. One port is up on each side. And what we're going to do here is we're going to say we're going to enable this at the interface level. No spanning tree, port fast edge, bpdufilter. I'm going to do this on both sides. So this is the global command, right? Okay, back to normal. Show run. Yeah, I want to test both modes. We'll do interface first. So with global mode, it acts different because with global mode, when you have it enabled and a port fast port receives a BPDU, it transitions out of port fast status and acts like a normal spanning tree port. So it goes through listening, learning, forwarding, right? If you have bpdufilter configured at the interface level, bpdufilter will simply ignore BPDUs coming in. That's what it's supposed to do anyway. So let's configure that. Let's say interface GI 00, spanning tree, port fast. Are we going to say network here? Oh yeah, and then we're going to say let's just see what we have. Okay, we're still getting BPDUs, right? We are sending and we are receiving BPDUs. Because we're saying we're a trunk port and we're port fast, so we skip the listening and learning phases, right? Now we're going to do spanning tree, BPDU, bpdufilter, enable. So what it's going to do is it's still going to send and receive, or it's still going to receive each port, I think. But it's just going to ignore them, or it should just ignore them. Look at that. It is effectively filtering them out. And basically turning off spanning tree because now this port will not participate in spanning tree. Let's turn it off on side 2. No spanning tree, port fast, bpdufilter enable. And we don't even see them in Wireshark. Like it's not, it's essentially just dropping the, hence the filter, right? It's just dropping the, now is GI00, is switch 1 sending any BPDUs to switch 2? Curious to see. Just CDP. Cool. So there it is, folks. It works. Now, let me see if I can get the global part working here. We're going to say no on this. This part I was not really, I'm not labbing this because it was something new or unexpected or anything like that. The reason I wanted to lab this, even though it's just a lesson, is I wanted to see what the interface looked like in global mode when we enabled it globally. So these guys, these ports are still, if I do show interface GI00 switch port, it does not, I think I have to do spanning tree. Show spanning tree interface GI00. I want to see the port fast information. Show spanning tree jazz 00 detail. There we go. Port fast network mode. Okay, and this is where we go. Oh, we didn't do the, that's okay. We didn't do the debug. Okay, so what I want to see here. Oh, it didn't take it off. Interface jazz 00, no spanning tree, BPD filter enable. Spanning tree, port fast, network. Show run interface jazz 00. Okay. Now we're going to do a global mode. And first we're going to do debug spanning tree BPDU. Wait a second. Okay, I turned off BPDU filter, so he is sending BPDUs. Okay, that's correct. Now what debug output do we see when we turn it on? Interface jazz 00, spanning tree. Yeah, now we know transmit. All right, so let's do the global configuration. Spanning tree, port fast, network options. No, what we want to do is port fast, normal, default. What was the command? Port fast. Oh, you cannot enable on network interfaces. So let's do this. Interface jazz 00, spanning tree, port fast, edge, trunk. There we go. Then global mode, spanning tree, port fast, edge, BPDU filter, default. And we're going to take it off the interface level. Interface jazz 00, no spanning tree, port fast. No spanning tree, BPDU filter enable. There we go. Okay. Now notice in this case, we got a blocking inconsistent port type. Okay, so now if we do show spanning tree, interface jazz 00. No, show, yeah, spanning tree, interface jazz 00 detail. Notice this time it's port of VLAN 1 is broken. So this is interesting because what I saw from the documentation is that in global mode, that port fast BPD filter would not block the port, but if it received a BPDU, it would just discontinue port fast mode of the switch port. In fact, I'm looking at this lesson. Global. If you enable BPD filter globally, then any interface with port fast will not send or receive any BPDUs. When you receive a BPDU on a port fast enabled interface, it will lose its port fast status, disables BPD filtering, and acts as a normal interface. Well, what we saw here is that is not the case. In this version of code, show interface status. See, it shows it as connected, but it is port type is inconsistent, and the port is broken. It doesn't say inconsistent here. It still says connected, though. So question is, oh, why does it do that? No, don't do that. There we go. Show BPD filter is enabled by default, right? So now do we see any traffic on this port? Like, is it blocking all traffic now? It says connected. Okay, it's not even sending CDP packets, so it's not sending any information. Oh, yes it is. So what does this mean, broken, then? If it's broken, why do you let me use it? I don't get it. I think the point here is you have to be very careful with BPDU filter. Generally, BPDUguard is preferred. And as we can see here, especially these newer models of, images, you're going to see some unusual behavior, I think. Obviously, this is still sending information, even though it says the port is broken. And that it is inconsistent. It's not sending, so it's not sending BPDUs. But it is sending other traffic. Show interface GI00 detail. Interesting. Okay, well, it's a little different than what we expected to see, but it's understandable. All right, folks, I think I'll save for tomorrow the are you different for certain iOS? Yes, it is different. It doesn't really tell me, mentors, like what version of iOS it's running. It's pretty generic information in here. I suppose we could look up. I think this is just a different version of iOS issue. Some of these network lessons are actually been around a while. Like if I go back to the forum replies, some of the forum replies were posted like quite a while ago. So yeah, this is just, I think, a different behavior. At some point, Cisco changed how it works. So, but yeah, I think I'm getting low on time, getting close to 8:45 here, getting close to old man's bedtime. I got a trivia question for tomorrow. Tomorrow we'll cover loop guard and UDLD. But here's a question for you. So what happens when you enable bpduguard and bpdufilter on the same switch or on the same interface? Yes, it's a little bit of a rabbit hole for sure, mentors. And it is fun going down this little rabbit hole. Fun stuff. So yeah, this is, if you have configured for both, what happens? I found this in a forum, in a networklessons.com forum reply. So someone asked a question, Renee or someone else came back and actually replied. They didn't know the answer, so they labbed it up and found the answer. So they've done it for us, and I'll be able to share that with you tomorrow, unless you already know, or unless you want to lab this yourself and give it a shot. Meat chunks, so UDLD, we didn't really get to that. We'll save that till tomorrow. There's a pcap for UDLD. There's actually, even though it's proprietary Cisco protocol, unidirectional link detection, there is an RFC for it, a request for comments, with some details there. So we'll talk about that more in depth tomorrow. If you are doing streaming or planning to stream or do YouTube videos, there's a really cool channel out there called Gaming Careers, YouTube/Gaming Careers, and they put out a new video, really well, it's high quality stuff. They put out a new video on setting up your OBS green screen filter, and I had followed some of the suggestions. There are some other suggestions I want to go back and improve upon, so I found it helpful. Maybe you will. And I just want to thank folks for stopping by tonight, man. We've been labbing for like going on, it'll be about 2 hours. Which is great. You know, we've been going through, again, some layer 2 stuff. I hope to get, again, my goal by the end of this week is get into, we've got loop guard, UDLD, spanning tree dispute, and spanning tree bridge assurance. Then there is RSpan, span, and ERSpan. I don't anticipate spending too much time on that. And there's switch virtualization, so that's VSS, Stackwise, and then multicast. That's where I really want to be. IGMP. I want to spend some time with IGMP version 1, 2, and 3, IGMP proxy, IGMP boundary filtering. So that's going to be some good stuff, but that's probably going to be for the weekend. But yeah, hang out with me some more, you know, and we shall see you tomorrow night. All goes well. Same time, same place, here on the Land Tamer stream. Thanks for the follows. Click that follow button if you haven't already. If you got an extra Amazon Prime, you know, with every Amazon Prime account, you get one free Twitch sub. So feel free to use that if you have one. You haven't used it yet this month. Click that sub button. You can sub to us on YouTube. Follow us on Twitter, Instagram, GitHub, you name it. And always trying to put out good content, screenshots, videos, stuff like that. Thanks so much for hanging out, folks, and we shall see you back here tomorrow. Thanks, chat, mentors, everybody else been in the chat, and y'all have a great rest of your evening. We'll see you back here tomorrow in the Land Tamer stream.